And in several cancers, for example, as I think Dr. Petty said this morning, the fingerprint of microRNAs is actually a better descriptor both of diagnosis and of prognosis than the gene array of full-length messages. So microRNAs is a big deal. The winner of last year's Lasker Award, the winner in 2006 of the Nobel Prize. You would have been very upset, given their central role in biology, if you looked for some characteristic fingerprint of microRNAs in this illness and did not find it. But they did. They found preliminarily, they found a pattern of microRNAs that seemed to be expressed differentially, or some downregulated, I believe, in this illness that distinguishes them from healthy controls. And based on what those microRNAs were and what genes they are known to control the expression of, they postulate that they are involved in T-cell activation and activation of chemokine-cytokine pathways. So yet first studies of chemokines and cytokines were measuring the molecules themselves. Then people measured the messenger RNA for those molecules. Now you're measuring the microRNAs that control whether those messages ever get translated into protein. And by 3 different ways of looking at it, most of the literature seems to suggest a role for T-cell activation, chemokine and cytokine production in chronic fatigue syndrome. What about treatments? Oh, one other thing about microRNAs. Someone raised the question this morning about whether discovering a fingerprint of microRNAs that seem to be associated with this disease might have therapeutic implications. And Dr. Petty answered appropriately cautiously, it could. And I would second that, because one of the hottest areas in biotechnology right now are companies that focus on microRNAs and use them as therapeutic agents. They are very attractive therapeutic agents. They are small and therefore easy to produce and cheap to produce. They can be protected after they enter the circulation, after they're injected, for example, from being degraded, and they can be targeted to host tissues, all of which was not so clear 5 years ago. And already in both animals and humans, there are preliminary but successful therapeutic trials, for instance, in patients with abnormally high cholesterol, of using a microRNA to damp down, to suppress the expression of genes that raise cholesterol levels, and that have worked very effectively. Whether in humans they'll prove to be better than statins is far from clear, but that the approach that the microRNAs can be therapeutic molecules, I think, is being validated in various laboratories. What about treatments? There were no studies really directly of treatment. There were some that involved treatment trials, but we're looking at physiologic markers. The ones that caught my interest, one non-pharmacologic, the cognitive behavioral stress management technique developed by Dr. Antoni in Miami, being telephone-based just struck me as a terrific idea, since so many patients are unable to participate in any kind of CBT therapy at the hospital. And if you could really deliver a home-based service effectively, I think it would be a big step forward. We don't know yet until the trials are done that can be done, but that they will be effective, but it was an interesting idea. Dr. Hone, or Ms. Hone's paper, used sodium oxybate in patients with CFS, and demonstrated, as one would expect based on what's known about the molecule, that it caused increased time in slow-wave sleep at night. And the patients reported, wasn't really clear what the details were here, clinical improvement in an uncontrolled study. Now, sodium oxybate has considerable abuse potential, and right now it's a pain to prescribe it. because you have to report regularly to the pharmaceutical company that manufactures it. But at least this is very preliminary data that suggests that medications that increase slow wave sleep, which is diminished because of the alpha intrusion that we talked about a minute ago, that such medications might plausibly be beneficial in this illness. Dr. Klimas reported that a molecule that enhances NK cell function seemed to have some clinical potential, and Dr. Carr pointed out that several of the genes that he has identified among the 88 that seem to be a marker for the illness in his study have at least suggest potential therapies, so they may have some therapeutic potential. So that is my Cook's tour, with 26 seconds left to go on the clock, to what I thought was a very exciting meeting where some theories that were previously promulgated and were sort of attractive but not well supported became better supported, and a couple of whole new approaches to studying this illness were presented that seemed to me to offer considerable potential for the future. So an exciting meeting. I hope it was for you. Fellow bitter enders, we are now adjourned. I guess Dan is going to formally adjourn us.
And I thank Tony again for a very masterful summary. I'm sure we'd all love a copy of that presentation, so the next time we go to update somebody on the area. Thank you, Nancy, very much. On behalf of the Whittemore Peterson Institute and all the others that organized this meeting, I really want to once again thank you for coming here. From a historical perspective, for me, it was very special. The first meeting I went to in 1986, I think there were 90 psychiatrists who presented and 2 clinicians. So it's really a very radical difference from that in the last 23 years. And I look forward to the future meetings and the kind of pathways we're going in terms of all the exciting stuff that Dr. Komaroff summarized.